Hi, my name is Chris Schaffer, and I'll be walking you through my assignment 3 for CSC 578. Over here on the left, we have the actual assignment website. First step is to load and prepare the data, and over here we have an HTML of the Jupyter notebook that I used to fulfill the assignment. So, to load in the data, after loading in the required modules and setting the random seeds, uh, we load in the data here, at least the training data, with this helper function. I got this, I think, from the same CFAR website that the data is from. They suggested using this, um, and it opens up the raw bytes that make up the files. Down here, we preview the training data, which is always good to get a grasp on what you're actually working with. It generates a random image from the stack. Guess we have a horse here. Then we open and preview the test data in much the same way, just to make sure it was read in correctly. This is part 2 of the homework assignment. I made it separate from my Kaggle submission because it just asked us to create something different. So here I mimicked what was requested in part 2 here. Here's the summary of the network. And then we train the model. Well, before we train it, we actually compiled it up here with categorical accuracy and the atom optimizer as requested. We go on to train the model. There are 30 epochs in this training session, and the results are recorded out here. Not so great of a performance out the gates. It looks like the accuracy is no better than guessing, considering there is 10 categories. You're likely to be 10% correct if you just randomly guessed. But fulfilling the rest of that, we go on and evaluate the model, and sure enough, the accuracy of our test data here turns out to be 10%. In an effort to create a richer and hopefully more accurate model, I decided to create synthetic data. I know this was suggested in one of the several emails that flew around for this assignment, and I think it has some merit. Um, I'm not entirely sure if it worked for me in a positive or negative sense, as I didn't notice too much of a difference after implementing it. However, I see the merit in it, like I said, and I think it's a good idea. So here, in this cell, we create a new set of images that are slightly modified originals, and we add them to the original stack. Here is the Kaggle model that I played around with and tweaked in order to create submissions. Um, Unfortunately, I was not the best at cataloging my history of model architectures as I went, but we ended up with something like this. One of the better models that led to one of my better submissions is captured, whoops, wrong assignment, is captured here in the PDF that I will also be submitting along with my homework. As it says here, this is the quick and dirty view of it. The convolution layers, a max pooling, more convolution, and then I figured the data was small enough to be handled after a single max pool, so then it's sent to the fully connected layers with dropout. Likewise, I include the code for that particular model. Um, that one used, let's see, optimizer type eta delta. I found the different etas, like atom, eta delta, eta grad. Those all were pretty sufficient at quickly converging on a solution. So yeah, here's the performance of said model. Again, it was one of my better submissions. I think my best was closer to 1 for the loss. And then for the sake of testing and evaluating, I have a couple plots of model accuracy and model loss, including some evaluation data, just to get that quick feeling for how the network is performing as I go and make tweaks. Here again is another good visual to just see how the network is deciding on its answers. So clearly it would choose category 3 for whatever this image is. However, it's interesting to see how much it thinks it might be another category. Ideally, we'd want to shrink these so we'd have as little loss as possible. And then this last cell was just used to write out a solution to a file or a set of solutions to a file, which was then used for submission. So that's a summary of my assignment. I will be submitting this and the video, and I hope you have a good day. Thank you.